All right, so today we are going to talk about the sum and difference formulas in section 5.4 in our textbook. And what I would stress about this section is that it is extremely formula-oriented. In fact, this whole chapter is very formula-oriented. It's knowing the trig identities from page 340. That's going to be an important section for the proofs. But now there are several formulas that are going to help us elaborate on some of the trigonometry that we already know, some of the unit circle work that we already know. So I would take a second, I would pause this video, I would have these trig identities visible for the next several slides because we're going to be using them on a pretty regular basis on just about every problem. So let's take a look here. On the very first question it says cosine, find the exact value, and I don't mean type it into your calculator and get a decimal approximation. That is not exact. What I mean by exact is there are, and so what I want to do is I want to use one of the sum of cosine formula here. So that sum of cosine, in case you don't have it already in your notes, cosine of u plus v is equal to cosine u, cosine v, minus sine u, sine v. And the idea here is I want u and v to be values that I already know that are on the unit circle, and of course I want them to add up to 75 degrees. So there's not a lot of ways to do that. In fact, the only way I could think of is
DJ Mitchell, this is the last call. Your transportation is waiting.
30 degrees plus 45 degrees.
Waiting outside. Thank you.
So now I'm going to be using that formula, and what I've really got is instead of being cosine u, now I've got cosine 30 degrees plus, or times cosine 45 degrees minus the sine of 30 degrees times the sine 45 degrees. Now all these values are on the unit circle, so I should know them. So I look and I say cosine 30 degrees, that is radical 3 over 2. Cosine 45 degrees, radical 2 over 2. Minus sine 30 degrees, 1/2. And sine 45 is radical 2 over 2. So I do a little bit of multiplication. Of course, both of those numbers are under the radical, so I can go call that radical 6 over 2. Radical 6, over 4. And then I say minus radical 2 over 4. Most of the time when you do this problem, it does come out to common denominators, which means it's extremely easy to write it as one fraction. Of course, those two radicals do not have the same radicals. You cannot subtract them. That is radical 6 minus radical 2, all divided by 4. All right, so that's using the sum, the cosine of a sum. Here we are going to use the sine of a sum. Or I'm sorry, actually going to be the difference of the sine of a difference is the easiest way to say it. Because obviously it would be very hard to come up with values on the unit circle that add to pi over 12. Not possible. Some people might not like working in radians. If you really hate radians, you could multiply by 180 over pi, and you would get that this is 15 degrees. If you really hate doing it in radians, you could. But let's do one in radians just for a sense of a little bit of difference. So here, the formula I'm looking at, difference here, sine u cosine v minus cosine u sine. It's a way to simplify the sine of a difference. And what could I subtract to get pi over 12? Well, if I take pi over 3 and subtract pi over 4, that's going to be pi over 12. So what I'm really looking at here is the sine of pi over 3 minus pi over 4. This is subtraction, so order matters here. So be extremely careful with your order. On the last one, it was an addition problem. Order didn't matter. I could have flipped that around. Here, order is going to matter. This first term is my u. This is my v, so I have to be very careful in my order. I'm looking at sine of pi over 3, cosine pi over 4, minus cosine pi over 3, sine pi over 4. And should be values I already know. Sine pi over 3 I know as radical 3 over 2. Cosine pi over 4, radical 2 over 2. Cosine pi over 3 I know that as 1/2. And sine pi over 4 I know that as radical 2 over 2. If you're asking where I'm getting all these values, these are right off our unit circle. We should have them memorized. So I do a little simplification. The top is very similar to the last problem. In fact, I think it's the same exact answer as the last problem. You get radical 6 minus radical 2 over 4. Now, those are two just completely different problems. I was lucky that they came out to be the same exact answer. But if you notice, these are exact answers. They are not decimals. They are not rounded. They are not an approximation of any type. Okay, so here I want to know the exact value of sine u plus v, and I'm giving you two pieces of information. I'm giving you sine u, and I'm giving you cosine v. Now I've told you it's in u is in quadrant 1. I've told you v is in quadrant 2. I am asking us to try to calculate the sine of u plus v, so I think this is a pretty straightforward formula. Sine u cosine v plus cosine u sine v. So here's the nice part. Sine u, I know how much sine u is. I know how much cosine v is. The two question marks is I don't know cosine u and I don't know sine v. But luckily I have enough information to figure them out, because if I know, in terms of, let's find cosine u first. So because I know y is 4 and r is 5, I could use x squared plus 4 squared equals 5 squared. I hope you've seen it enough. X squared plus y squared equals r squared. You can solve this. I hope you recognize it's a 3, 4, 5 right triangle. So I'm going to be able to say that is x is equal to 3. In quadrant 1, everything's positive. So I would know cosine u is equal to 3/5. All right, so now I actually know cosine u. I'll be able to substitute that in. And cosine v, well, if I know x and r, I'm going to use the same exact trick. Negative 12 squared plus y squared equals 13 squared. You may or may not know this one. All right, so you subtract the 144, get that to cancel. Y squared equals 25. And here we would get y equals 5. In quadrant 2, your x's are negative, which we have. Your y's are positive, so that's going to be positive 5. And we're going to be able to say sine v is equal to 5 over 13. So now I know all four, and now that I know all four, it is straightforward substitution. The key to this problem is knowing x, y, and r. So sine u, they told me that's 4/5. Cosine v, negative 12 over 13. They told us that as well. Now it's a plus sign, and it's the information that we found out. I found out cosine u is 3/5. And it's the sine v from over here, right? So these two pieces of information are what we're using in these last two parts. Sine v is equal to 5/13. And now it's just multiply and add. So if I do a little multiplication, that's negative 48 over 65 plus 15 over 65. Again, you're going to notice these common denominators come out most of the time. So I can just add those numerators. Negative 33 over 65. You can't even simplify that, so you leave it as is. All right, so here's a little proof to try to prove the cosine of pi over 2 minus x is equal to sine x. Now it's a proof. This is a formula, one of our cofunction identities. I told you it was true. Now I want you to actually prove to me that it's true. And the way we're going to do that is we're going to use that cosine formula. Cosine u minus v is equal to cosine u cosine v plus sine u sine v. That's the formula we're using. The only difference is this is u, this is v. So let's write it out. If I expand it and write it like that, it's going to look like cosine pi over 2 times cosine v, cosine x, not v anymore, plus sine pi over 2 and sine v. I'm sorry, sine x. Whoa, I keep using the wrong variables. All right, I should know the cosine of pi over 2. I should also know the sine of pi over 2. Cosine of pi over 2, this whole piece is 0, and 0 times cosine, if this whole piece is 0, 0 times cosine, this entire portion is 0. I don't need to write anything because now it's 0 plus. The sine of pi over 2, I know that is 1, so what am I looking at? I'm looking at 1 times sine of x. 0 plus 1 times the sine of x is equal to the sine of x. This is a relatively straightforward proof. Given that you've done proofs in the last few sections, this one isn't terrible. And it's hard to actually show because it's only a few steps. It's hard to show some work here. All right. So similarly, I'd like us to simplify here. So using the same formula from last time. So cosine u minus v is equal to cosine u, cosine v, plus sine u, sine v. If I use that again, so same exact formula from the last problem, this would read cosine theta minus the times the cosine of 3 pi over 2 plus sine theta times the sine of 3 pi over 2. Now, these two values right here, these are on the unit circle and I can calculate them. All right? I should know that cosine of 3 pi over 2 is 0. This is 0. This whole value right here is 0. 0 times whatever cosine theta is. This whole piece is going to be 0. I don't even need to write it. It's 0 plus, if you want to be fancy. Sine of 3 pi over 2. Sine of 3 pi over 2, that's on the y-axis. That's negative 1. This whole piece is negative 1. So it's negative 1 times sine theta. I switched the order around. And what does that simplify to? It simplifies to negative sine theta. Now, so that's a simplification. We could have also proven that, but this is just as good. We will open the next video starting with this problem.